Okay, guys, here we go again. Graphs that enlighten and graphs that deceive. Good graph versus bad graphs. You're going to just take quite a bit of notes on this one, and just warning you ahead of time. I'm gonna try to keep it as short as possible, lengthwise, but probably just stop it quite a bit and get some stuff down. So just a heads up there. Um, our objective today, or in the video, is to identify suitable graphs that represent the data. All graphs that you see should be effective in revealing the important characteristics, not just how they look. They don't need to look pretty, obviously, but these represent what the data set looks like. A couple of batteries in here. Some graphs are bad because they contain errors. That's obviously bad. Most of them don't, though. Most are bad because they are technically correct, but they mislead. And you're going to see some of those toward the end of the video today. It's important to develop the ability to recognize bad graphs and identify exactly how they're misleading. Now, don't get so caught up in identifying bad graphs that you miss the good ones. There are a lot of very good graphs out there. What we did earlier this week, histograms are great graphs, not misleading at all. So there's a lot of very good ones, and there's a few bad ones too. We're going to check them out right here. These are going to be good ones. First, several are good ones. Scatter plots, and I'm assuming you've seen scatter plots before. The data in this one represents, I don't know if you can read this or not, but it's waist circumference down here and arm circumference. And if you look at the points on the graph, they are kind of, they're increasing at this, as waist circumference is going up, so is arm circumference, which I guess you kind of expect that, the fatter a person around the waist, usually the fatter the arms, and skinnier. So that makes sense. Now remember, correlation does not imply causation, so don't forget that. But it is used to determine if there's a relationship between the two. And obviously in this one there is, because they're pretty close to a line. A time series graph. I'm not sure why it keeps popping up. A time series graph is also a good one. And all it is it shows you what's happening over time. If you look at the bottom axis down here, those are years. The data going up are, what it says is the yearly highs of the Dow Jones, which measures the stock market measure. And you can just tell by looking at the time series graph what's happened since 1980 to 2000, about 2010 there. And man, it'd be nice to have some money in there. 1980 all the way to 2010, you'd be very well off right now. But time series graph, another great way to show data. A dot plot. It keeps on coming up. The dot plot is just basically every single data point is represented by a dot. And if they're the same number, like if you see this big stack right here, that means there's a whole bunch of, that looks like probably 95. Looks like there's a whole bunch of 95s. This is that same low lead group that we've been dealing with for, this whole chapter. And you can see somebody's way out here, that's an outlier. Somebody's way down here, that's an outlier. But it shows you exactly where the data is. That's not misleading at all. You can see every single data point on a line, which is pretty nice. Stem plot or stem and leaf. Most people go with stem and leaf plots. This is also great. This is the same data you just saw, and it's better in one sense in that instead of using dots, you can see exactly what the values are. Like there's a 5 right here. The 0 and 6 represent that's a 50 and a 56. If you're looking at this row right here, it's like that stands for 91, 92, 93, 94, 94, 94, 95, etc., etc. It kind of shows you that. I guess I'm making it up, and it shows you that right there. But stem and leaf plots also very good way to show data. And also think about if you turn that stem and leaf plot up sideways, it would look just like a histogram. I think if you can see what I'm saying, with the classes, like the classes would be 50s, 60s, 70s, 80s, and it'd be a perfect little histogram there. Nice chart. Bar graphs. First of all, make sure when you see a good one that the bars have equal length, and they can show categorical, qualitative. The vertical scale is usually frequencies or relative frequencies, which we did earlier this week. A multiple bar graph. You can actually use 2 bars on the same graph, and I'm going to show you one on this next slide right here. Very interesting. This is a multiple bar graph. I don't know why that's okay. Multiple bar graph. So what this is medium income by gender, and they even did made the males blue, the females pink. That may upset some of you, but that's what they did here in this bar graph, and they're comparing the two. And as you see, as the years go by, on the bottom all the incomes came up, which hopefully that does happen, but there's still a gap, which that shouldn't be the case. We can debate all day what the reasons are for that. It doesn't really matter. This is just data only. This is just showing this is true data. By the way, the data we present from this book and from videos and things, 92% of it is actual real data. So this is actually from 1950 to 2010 is actually real data. Gosh, a Pareto chart. A Pareto chart is another bar graph, but what it does is it takes the percentage of the data and gives you, it goes down in value as you go. And this is really nicely used for categorical data especially. This chart right here that you're looking at, if you can see it or not, on the bottom, is like what contributes the most to happiness. Families and partners are the most, about 65%. Friends, about 15%. Leisure, sports, all the way down here at about 3% or whatever. And it will go. A Pareto chart does decrease as it goes to the right, and it's all based on percentages. So that again, that's a great way to look at stuff. A good bar graph, Pareto chart. A pie chart. This is exactly the same data from the last slide, except it's done in slices of a circle, and based on proportion. I'll be honest, most statisticians do not like pie charts. They think they're a waste of ink, and because you can't really tell percentages in there. You just kind of look at it and you're taking a guess at what what percentage it is of a circle. So that's kind of hard. But a pie chart, it is a way, and it's really not a bad one because it's not deceiving. It's just kind of a waste of ink and doesn't really tell you quite as much information, but not bad. A frequency polygon. These are our IQs again of the low lead group, and what this is, they take They take the classes that we had in our histogram earlier, and take those. Those are probably those are the boundaries, and for 79.5, 30 people were in that class. In this one, in the 99.5, there were 32 or whatever. Way up here, it was only about 10. So it's just it shows you a frequency distribution like we did earlier this week. Oh, it does say midpoint values. I was messing that up. Midpoint values of the classes. It's just a frequency distribution shown as a polygon, and it kind of gives you almost a normal shape there. A relative frequency polygon, the same thing, except now we're doing percentages or proportions. It's the only difference. Instead of having the actual numbers over here, how many is the percentage, and then you can compare the two. Easy to compare two groups on one graph right there. But all of these graphs we've seen so far are not trying to deceive anybody. They're using straight up data for to get the graphs. So they're all very good looking graphs. The last one is called an ogive. It is ogive, and it depicts cumulative frequencies. So this is the same thing. This is the same low lead group again. And if you pick a point on there, like this one right here, they picked a point, and it says, since it corresponds to 35 over here, it means that 35, since this is cumulative, 35 of the IQs are below 89.5. If you go up to here, that's 109.5, and kind of drew a line over there, 70 of the IQ scores are less than 109.5. And then once you get up here, at the top, that's probably the top one. So all of the IQs, because there's about 80 in that table, I guess, 80 of the IQs are below 149.5, which, makes sense because that's the highest one. So an ogive, cumulative. Still good, though. Not deceptive at all. All these so far have been really good graphs. Okay, here we go. Graphs that deceive. This is what you got to watch out for. These two graphs, these two bar graphs, believe it or not, I probably can't read it. These are miles per gallon with a Honda Civic, a Chevrolet Aveo, and a Toyota Camry. Same thing. Both graphs are the same thing. The only difference is this first one does not start at 0. It starts at 30, which makes it look like the Camry is so much less than the Honda Civic. But when you start the bar graph at 0, all of a sudden they're very close to each other, so very deceiving. If you're a Honda dealer, you're probably using this one. If you're a Toyota dealer, you're using the truth, starting at 0. So got to really watch for that. That thing keeps popping up. Pictographs. You got to be really careful here. Pictographs uses pictures of drawing or of objects. You got to watch for money bags, stacks of coins, army tanks, believe it or not, people, barrels, houses for home construction, different things. You got to really watch because they can create false impressions very easy that distort the data. Not that they're lying, but the pictures can really mess with you. This is a pretty good one. If you double each side of a square, the area does not merely double, it increases by a factor of 4, which is crazy. Most people don't know that. So let's say, well, let's make a square twice as big, but really you just increase the volume by 4. So gotta be careful there. Pictographs using areas and volumes can therefore be very misleading. Be careful when they use pictures. I'm going to show you a couple here before we end this video right now. Okay, this is income based on education. What they did is they took a piece of a dollar bill and talked about, well, if you have an advanced degree, you're going to make this much, that much of a dollar bill. Bachelor's degree, that much. High school diploma, that much. And if you don't have any high school diploma, only that much of a dollar. And that's really kind of hard without those numbers out to the right-hand side. And even with the numbers, if you look at this, the highest one is 74,000. The paper-wise, it doesn't look like as big as it really is. Like this is about 4 times bigger, but it's hard to tell if that dollar sign is 4 times bigger. And here's the exact same thing with cubes. Very misleading because, again, this cube right here is actually, I know it doesn't look like it, but if you do the volume, it's 64 times as large as the first box, but the income's only 4 times as large. So again, use of pictures, very tough. Also, usually very deceiving. Okay, here's actually a good one, believe it or not. This is just a bar chart with income and education, and absolutely nothing wrong with that. And it shows exactly the difference. It starts at 0, shows you what it is on the bottom, the education level, the income going up the side. Nothing distracting. That's just perfect. All right, and the last thing here, some principles suggested by Edward Tufte. These are really good. If you have a small set of data, 20 or fewer, always use a table instead of a graph. No need to graph that few points, just use a table. Frequency distribution table, some kind of table. A graph of the data should make the viewer focus on the true nature of the data, nothing else. Don't worry about it being eye-catching or distracting, have distracting design features. This is a big one. Don't distort the data. Make sure your graph reveals the true nature, and that's where people trying to sell stuff will do whatever they can, so you got to be careful. And almost all the ink in a graph should be used for the data, not to make it look beautiful. You're not trying to impress anybody, just trying to have a nice, good representation of what the data looks like. So quite a bit of stuff in there. Hope you got a lot of that down. See you in class tomorrow to work on some of these. See you, bye.